Hi guys, welcome to our channel of Sciences and Mathematics. So today we're going to look at one of the processes in electrophilic substitution aromatic reaction, and that is a process of desulfonation. Now desulfonation is a reverse process of the process that we have discussed about in one of our videos, and that is the process of sulfonation that we have talked about. Now we said that in sulfonation the electrophile that is used comes from the mixture of what we call fuming sulfuric acid, which is a mixture of sulfur trioxide and sulfuric acid, of course, which forms what we call fuming sulfuric acid. So in this case, desulfonation is a reverse process, and in chemistry, of course, we know that a reverse process is a process that takes place from the initial to the final stage. So this one can just be symbol representation for a reverse process or a reversible reaction. So in this case, we have an initial stage to the final stage. This is the final stage. And then for a reversible reaction, the reverse process can be achieved whereby there is a final stage. The products at the final stage can be taken to the initial stage, of course, without change. This is without change of the environment or without change of the system, change of the system or surrounding. So these specific terms that we've used at this particular point in the reversible reaction are the terms that, of course, we discuss in thermochemistry, which pertains to the relationship between the reactants and the product and the surrounding. So in this case, for a reversible reaction, is a reaction that can be achieved from the initial to the final, or from the final to the initial stage, without change of the system or its surrounding. So desulfonation is one of those processes, and we're going to just give a simple demonstration. Now in this desulfonation process, we're going to find out that this process entails the reacting benzene sulfonic acid with steam, which is a gaseous form of water that will form benzene and sulfuric acid in the process, of course, achieve the products of benzene and sulfur trioxide. So for the general reaction for this, we're going to have this benzene sulfonic acid that is, of course, reacting with the steam. So I'll indicate this one. This is water at 135 to 200 degrees centigrade. So in this case, it indicates that this is a range of temperature that is needed for this reaction or the products to be achieved, and we shall have benzene as the product plus sulfur trioxide. Of course, in water, that one will form an acidic compound, but in this case, these are the products which are achieved. And now we are going to look at a reaction mechanism that is going to lead to the formation of these products, or this reversible process of sulfonation that we have talked about and called desulfonation. So I'm just going to use these three molecules to write a summary of the reaction mechanism that is taking place. So from this point, we shall have our initial product, which is benzene sulfonic acid, which was formed from the process of sulfonation. And I use half arrows to indicate that this process is reversible. Remember the arrows that we had used, the double-sided arrows that we had used to imply resonance. Now for this, we are going to use to imply that the process is reversible for those half arrows. So in this case, there is an intermediate product that is formed, which of course has got a proton at this point, and then that is from the electrophile that had formed. So in that case, we shall have in this mixture that nucleophile that is going to pick. Now in this case, it's not going to pick a proton, of course. It's going to pick this. Of course, it's going to pick a proton from now not this carbon hydrogen bond, but it's going to pick up a proton from this part of the nucleophile that had part of the electrophile that had attached here. So in this case, it's going to pick a proton from this point, and then so not a proton really. It's going to pick that from that point, and then this molecule will move at that point. Remember, there's a H group at that point, so it's going to move to that point, and that is the last stage that is going to restore the aromaticity of this compound. So in this case, of course, we're going to see that this bond is going to break away. This proton that is a carbon hydrogen sigma bond is going to be maintained, and then this one is going to break away, and there's going to be a rearrangement. This one will lead to the formation of the sulfur trioxide from this product. Now that the proton has been taken away and this bond has broken, so that's going to form that final product. But in this initial stage, of course, we'll have what we call an hydronium ion. That is, of course, an electrophile, and this arene bond had picked that ion from there, and this one, of course, moved in order to counter that. So there will be a product, of course, another product that is formed apart from this. So in this case, for this reaction proceeds in that order. So from this one, benzene sulfonic acid, the arene part of the molecule attacks this proton at that particular point, and this bond moves at that point in order to stabilize the product that comes from there. And this product is reversible with the intermediates, so we can be able to achieve this. And then you find that this is a nucleophile that attacks the hydrogen at that particular point. That is from the part of sulfuric acid, or the electrophile that have been attached in the sulfonation process. And then you find that this bond will move in order to restore the aromaticity of that compound and break away. So this product will form sulfur trioxide, and then that aromaticity will be restored in order to form the product, which is benzene and the sulfur trioxide. So in this case, this is a this is a reversal, the reverse process of sulfonation that we have talked about, desulfonation. And these reverse processes are very important in studying some of the reaction mechanisms that may be taking place in forming different compounds. It can also be achieved of assistance in trying to find, of course, the energy that is used in formation of different molecules, or the procedures or the mechanisms that I've talked about. So we're going to see more of these kind of examples as we move by. So for that case, that is it for today. Bye guys. Thank you. God bless you.